Imagine a quiet evening. The sun is dipped below the horizon, painting the sky in soft shades of purple and orange. A dramatic single star appears over a silhouetted tree line. A cool breeze whispers through the trees, carrying the gentle sounds of the world settling down for the night. You are standing in a backyard, perhaps your own, with the damp grass cool beneath your feet. The first star appears. It is a tiny, steady pinprick of light against the deepening blue. It seems so close, so simple. It is a sight humans have witnessed for thousands of years. It is a familiar and comforting part of our world, a silent companion in the vast darkness above our heads. This single point of light holds more stories than we could ever imagine. Look up. More stars begin to emerge as the last of the sun's glow fades away completely. They are not all the same. Some shine with a fierce, unwavering brightness, while others twinkle with a gentle, pulsing rhythm. Some appear white, others have a hint of blue or a warm, reddish hue. They form patterns we have given names to, constellations that our ancestors used to tell stories and navigate the seas. These distant suns seem peaceful and eternal from our small vantage point. But each one is a churning, burning sphere of immense power, a nuclear furnace millions of miles away. That single point of light you first saw is not just an object. It is a place, a history, a destiny. Beside you, a small hand slips into yours. It belongs to a child, their face turned upwards, their eyes wide with a pure and honest wonder. For them, the world is still a place of magic and endless questions. They see the sky not as a collection of scientific data, but as a giant sparkling canopy filled with mysteries. Their curiosity is a powerful force, a natural human instinct to understand the world around us. It is the same curiosity that drove early astronomers to map the heavens and modern scientists to build giant telescopes that can peer into the deepest corners of space. The child raises a tiny finger, pointing with great seriousness at that first, bright star, the one that arrived all alone before the others. To them, it is special. It is their star for this moment. The air is still. The world seems to hold its breath, waiting. The child's gaze is fixed, their mind racing with thoughts that we, as adults, have often learned to ignore or push aside. They are not thinking about mortgages or deadlines. They are thinking about the biggest things possible. They are about to ask a question that will set us on an incredible journey, a journey that spans all of time and all of space. The child turns to look at you, their eyes reflecting the distant starlight. The question they ask is simple, yet it is one of the most profound questions a person can ever pose. It is a question that is echoed through human history, whispered in every language, and contemplated by the greatest minds who have ever lived.
Where did it come from?
The words hang in the cool night air, small but heavy with meaning. They are not just asking about a dot of light in the sky. They are asking about origins. They are asking about the very beginning of things. This question is not just about astronomy. It is about connection. Where did it come from? And by extension, where did we come from? The child senses, on a deep and intuitive level, that the story of that star is somehow connected to our own story. They are right. The answer is not a simple one. It is not a single location or a single moment in time. The answer is a grand and sweeping saga that begins long before that star was born, long before our sun, and even long before our own planet Earth took shape. It is a story written in the fabric of the universe itself. To answer this question properly, we cannot stay here in this quiet backyard. We must travel. We must leave behind our familiar sense of scale, our understanding of minutes and hours, and embrace sizes and timelines that are almost too large for the human mind to hold. We must journey across the universe. Think of this question not as a puzzle with one right answer, but as a key. It is a key that unlocks a hidden door. On the other side of that door is a spectacle more amazing than any fantasy, a reality more incredible than any work of fiction. It is the story of everything. And so we will accept this challenge. We will take that simple, powerful question as our guide. We will embark on an adventure together, a 60-minute voyage across the cosmos. We will travel from this blade of grass to the edge of the observable universe. We will witness the birth of stars and the creation of worlds. We will explore the building blocks of life itself and confront the deepest mysteries that still remain. The journey starts now with this one question under this one sky. Hold on tight, because the universe is waiting to reveal its secrets to us. Our journey will not be like any other you have taken. We will not be traveling in a straight line. Instead, we will be moving through ideas, through time, and through immense, breathtaking spaces. Our vehicle will be our own curiosity. Our map will be the laws of physics. Our destination is a deeper understanding of our place in the cosmos. We will begin by leaving our backyard and seeing our own planet from a new perspective. Our neighborhood, our city, our country shrink away until the entire Earth is a beautiful blue and white marble suspended in the blackness of space. This is our home. From there, our tour will take us through our own solar system. We will fly past the rocky, cratered surface of our moon. We will feel the immense heat of the sun, the star that gives us life. We will glide through the asteroid belt, a cosmic junkyard of leftover building materials. We will marvel at the majestic rings of Saturn, the swirling giant storms on Jupiter. Each planet is a world unto itself, with its own unique character and its own secrets. Seeing them up close, you will understand our solar system is a place of incredible diversity and dynamic energy, a family of worlds orbiting a single ordinary star. But our solar system is just one of countless star systems in our galaxy, the Milky Way. Our next step will be to pull back even further. The planets will shrink to invisible specks. Our sun will become just one of hundreds of billions of stars, a swirling, majestic spiral of light and dust. From this vantage point, you will see the true scale of our cosmic city. We live in a vast, flattened disk of stars, gas, and dust. And we will not stop there. We will travel beyond our own galaxy to see that it, too, is just one of billions of galaxies, each one an island universe containing billions of stars of its own. This is the promise of our grand tour, to show you the universe as you have never seen it before. We will use the power of science and imagination to make these vast distances feel real. We will create a three-dimensional map that you can move through, feeling the scale in a visceral way. You will float through glowing nebulae where new stars are being born. You will witness the explosive death of a massive star in a supernova, an event that forges the elements of life. This journey will be more than just a collection of facts. It will be an experience, a flight through the heart of creation. This journey is for everyone. You do not need a degree in physics or mathematics to come along. The only ticket required is your own sense of wonder. The universe is not the exclusive property of scientists and labs. It belongs to all of us. It is the shared heritage of every human being who has ever looked up at the night sky and felt a sense of awe. We will use simple language, clear ideas. We will use metaphors, familiar comparisons. The cosmos is telling the greatest story of all, and it wants to be understood. Think of this experience as a movie, one you can step inside of. There will be moments of quiet reflection, moments of heart-pounding action. We will use vivid sensory details to help you see, hear, feel the universe around you. Imagine floating in the silent emptiness between galaxies, islands of light scattered in every direction as far as the eye can see. Imagine feeling the gravitational pull of a black hole, a place where the laws of physics are pushed to their absolute limit. As we travel, we will encounter not just facts, but also big questions. The universe is full of mysteries. What is dark matter? What is dark energy? Are we alone, or is the cosmos teeming with life? These questions do not have easy answers, but that is what makes them so exciting. They are an invitation to keep exploring, keep learning, keep dreaming. Science is not about having all the answers. It is about the thrill of the search, the joy of discovery. So take a deep breath. Let go of your everyday concerns for just a little while. The child's question, "Where did it come from?" is our starting point. The answer is everything. The story of that one star is the story of the Big Bang, the creation of atoms, the formation of galaxies, the birth of our sun, the long, winding road that led to life on Earth. It is our story. Your ticket is in your hand. The journey across the universe begins now. Our journey begins with a single step, but it is a giant one. We are rising up, leaving the familiar comfort of the backyard behind. The grass, the trees, the house, they are all shrinking below us. We float upwards, higher and higher, as if we are in a silent, invisible elevator. Soon, the entire neighborhood is visible, a neat grid of streets and rooftops. Then our city comes into view, a sprawling network of lights and life. We keep rising, and the shapes of coastlines and mountain ranges begin to emerge. The world we know is quickly becoming a map laid out beneath us. The curve of the Earth becomes apparent, a gentle arc against the blackness of space. Clouds swirl in vast, silent patterns over deep blue oceans and continents of brown and green. We see the thin, fragile layer of our atmosphere, a delicate blue haze clinging to the edge of our world. This is the air we breathe, the shield that protects us from the harshness of space. From this vantage point, there are no borders, no divisions between countries. There is only one planet, one shared home for all of humanity, floating in the vast, empty void. Let's pause here for a moment and look back. See that beautiful, swirling blue and white sphere? That is everything you have ever known, every person you have ever loved, every song you have ever heard, every meal you have ever eaten. All of it happened on that small, fragile ball. It is an oasis of life in what appears to be an endless desert. Seeing it from this distance gives us a new perspective. Our daily problems and conflicts seem to shrink in the face of this silent, majestic beauty. We are all passengers on this one spaceship, traveling together through the cosmos. This is our starting point, our pale blue dot. Now let's turn around and face the darkness. Our journey has just begun. We have only traveled a few hundred miles from the surface. In cosmic terms, we have barely even left the front porch. The star the child pointed to is still incomprehensibly far away. To reach it, we must first cross the vast expanse of our own solar system. The backyard is gone. The Earth is shrinking behind us. Ahead lies the grand, open territory of our solar system. Let's move deeper into our cosmic neighborhood. Our first stop is the Moon, Earth's constant companion. It is about 240,000 miles away. That sounds like a big number, but let's try to make it feel real. If you could drive a car to the Moon at a steady highway speed, the journey would take about 6 months. It is a barren, silent world, covered in craters and fine gray dust. But from its surface, we can look back and see our Earth hanging in the black sky, a vibrant jewel of color and life. This view, seen by only a handful of human beings, forever changed our relationship with our own planet. Now let's pick up the pace and head toward the center of our solar system. We are moving towards the Sun. It is a star, just like the one the child pointed to, but it is our star. It is about 93 million miles from Earth. The sheer size of it is hard to comprehend. You could fit more than 1 million Earths inside the Sun. It is a gigantic ball of hot gas, a nuclear furnace that has been burning for more than 4 billion years. Its immense gravity holds our entire solar system together, keeping every planet in its orbit. Its light and heat make life on Earth possible. From the Sun, we can look outwards at the rest of the planets. We see the small rocky worlds of the inner solar system: Mercury, Venus, Earth, Mars. Then, beyond the asteroid belt, we find the gas giants. Jupiter. Jupiter is so large that all the other planets in the solar system could fit inside it. Its great red spot is a storm that has been raging for centuries. A storm larger than our entire planet. Saturn, Uranus, Neptune. These are enormous worlds, completely different from our own. The distances here are staggering. To travel from the Sun to Neptune, the outermost planet, you would have to cross nearly 3 billion miles. A commercial airplane flying non-stop would take over 500 years to make that journey. This is our solar system, our family of worlds. It is a place of incredible variety, from the searing heat of Mercury to the frozen, distant plains of Pluto. And yet, this entire system, which seems so vast to us, is just a tiny, isolated speck in the grander scheme of the universe. To continue our journey, we need a new way to measure distance. To travel beyond our solar system, we need a faster way to move and a better way to measure the immense distances involved. Miles, kilometers, become too clumsy and large to be useful. Instead, astronomers use a different kind of yardstick: the speed of light. Light is the fastest thing in the universe. It travels at an incredible 186,000 miles per second. That is fast enough to circle the Earth more than 7 times in a single second. Nothing we know of can travel faster. So we measure cosmic distances not in miles, but in the time it takes light to travel that distance. Let's apply this new yardstick to our solar system. The light from our sun does not reach us instantly. It takes about 8 minutes and 20 seconds to travel the 93 million miles to Earth. This means that when you look at the sun, please don't do this without proper protection, you are not seeing it as it is right now. You are seeing it as it was over 8 minutes ago. If the sun were to suddenly vanish, we would not know about it for 8 minutes. We are always looking at the past. The farther away an object is, the further back in time we are looking. Now, let's extend this idea. The light from our sun takes about 5.5 hours to reach Pluto, on the edge of our solar system. A light year is the distance that light travels in 1 full year. This is not a measure of time, but a measure of distance. It is an enormous distance, nearly 6 trillion miles. Using this measurement, the nearest star to our sun, Proxima Centauri, is about 4.2 light-years away. This means the light we see from that star tonight started its journey more than 4 years ago. It has been traveling through space that entire time, just to reach our eyes. Think about what this means for our journey. The star the child pointed at is likely tens, hundreds, or thousands of light-years away. The light from that star began its journey long before that child was born. As we look out into the universe, we are looking into a deep well of time. The farther we look, the older the light is, and the further back into history we can see. This is our time machine. Now that we have our new yardstick, the light year, let's take our next great leap and pull back from our solar system. Our sun, once a giant furnace, shrinks to a bright point of light. Soon, it is just one star among many. We see our local stellar neighborhood, but we must go further. We pull back at impossible speeds until we can see the entire structure to which our sun belongs. We are looking at our home galaxy, the Milky Way, a breathtaking, vast, swirling spiral of stars, gas, and dust. The Milky Way is our cosmic city. An estimated 200 to 400 billion stars. Our sun, just one ordinary medium-sized star living in a quiet suburban neighborhood of this city. The galaxy is a giant flat disk with a bright bulge at the center. The disk is about 100,000 light-years across. Even at light speed, crossing it would take 100,000 years. Our solar system is a tiny, invisible dot inside this immense structure. Our sun sits in one of the spiral arms, about 27,000 light-years from the galactic center. We slowly orbit that center with all the other stars. One orbit takes about 230 million years. The last time we were here, dinosaurs were beginning to walk the Earth. The universe's sense of time makes our history seem brief. We are on a slow, majestic carousel ride through the cosmos. Look up on a clear, dark night away from city lights. A faint milky band stretches across the sky. That is the Milky Way. You're looking into our galaxy. The combined light of billions of stars fills the view. A humbling reminder, we are not at the center of the universe, nor even of our galaxy. We live on a small planet, orbiting an average star, in a suburban arm of a vast city of stars. Our journey is not over. Our galaxy, as vast and magnificent as it is not alone. It is part of a small cluster called the local group. Think of it as a small county. The Milky Way is one of the largest members, and our nearest major galactic neighbor, the Andromeda Galaxy. Andromeda is another majestic spiral, slightly larger than ours. It sits about 2.5 million light-years away. The light we see left 2.5 million years ago, back when early human ancestors walked the African plains. With the naked eye, Andromeda is the most distant object you can see. It looks like a small, faint, fuzzy patch. But that fuzzy patch hides a city of 1 trillion stars. The local group contains more than 50 galaxies. Most are much smaller than the Milky Way. They are called dwarf galaxies. They orbit the larger ones like moons around a planet. A gravitational dance on an unimaginable scale. Andromeda and the Milky Way are more than neighbors. They are on a collision course. Pulled by mutual gravity, they hurtle toward each other at about 70 miles per second. Do not worry. The collision won't happen for another 4.5 billion years. When it happens, it won't be a destructive crash. Stars are far apart. They will mostly pass by one another. Over hundreds of millions of years, the two will merge into one giant galaxy. What lies beyond our local group? If we continue to pull back, we will see that our small cluster of galaxies is not isolated. It is part of an even larger structure, the Virgo supercluster. As we continue to zoom out, an incredible pattern begins to emerge. The galaxies are not spread randomly throughout space. They are arranged in a gigantic, beautiful structure that looks like a web. This is the cosmic web. In between these filaments are vast, empty regions called voids, where there are very few galaxies at all. Imagine floating in one of these great cosmic voids. It would be a place of profound emptiness and darkness. Our Milky Way is located within one of these filaments. We are part of this grand interconnected structure. We are not lost in the void. We are part of the web. This structure tells us something fundamental about how the universe began. The tiny, subtle variations in the early universe, moments after the Big Bang, were the seeds of this cosmic web. Gravity acted on those tiny differences over billions of years, pulling matter together to form the first stars and galaxies along these filaments. The largest structure we can see in the universe today is a direct echo of the smallest fluctuations at the very beginning of time. The very big and the very small are connected in the most intimate way. So far, our journey has been mostly about scale, about the immense size of the universe. But as we discovered, with the speed of light, distance, and time are deeply connected. When we look far away in space, we are also looking far back in time. This is one of the most powerful ideas in all of science. The telescope is a time machine. With the Hubble Space Telescope and James Webb Space Telescope, we can look at galaxies that are billions of light years away. We can see galaxies as they were when the universe was much younger. When we look at a galaxy 10 billion light years away, we are seeing light that started its journey 10 billion years ago. At that time, our own Sun and Earth did not even exist. They would not form for another 5 billion years. What do these young galaxies look like? They are different from the galaxies we see nearby. They are often smaller. They are often more chaotic. They are often more irregular in shape. They are filled with bright blue, massive young stars. They are undergoing furious bursts of star formation. We can see galaxies colliding, we can see galaxies merging, a common event in the crowded early universe. By looking at galaxies at different distances, we can piece together the story of how galaxies evolve over time. We can see them grow from small, messy collections of stars into the grand, majestic spirals we see today, like our own Milky Way. This journey back in time takes us closer to answering the child's original question: where did it come from? The star they pointed to did not just appear out of nowhere. It was born from gas and dust inside a galaxy. That galaxy itself formed from smaller pieces over billions of years. And those pieces were formed from the matter created in the Big Bang. By looking deep into space, we are looking back towards the origin point of everything. We are seeing the history of the universe unfold before our eyes, one distant galaxy at a time. The past is not gone. It is written in light all around us. The age of the universe is about 13.8 billion years. To make this immense span of time more understandable, let's compress the entire history of the universe into a single calendar year. In this cosmic calendar, the Big Bang happens at the first instant of January 1st. The present moment, right now, is the last tick of the clock at midnight on December 31st. Using this scale, every month represents a little over a billion years. Every day represents about 40 million years. On this calendar, the Milky Way galaxy does not form right away. It takes time for the first stars. Small galaxies coalesce. Our own galaxy begins to take shape around May. The solar system, our sun, Earth, the other planets. It does not form until early September. For the first 2/3 of cosmic history, our home did not exist. Life on Earth begins to stir soon after, around late September. First single-celled organisms. Complex life takes a very long time to develop. The dinosaurs appear around Christmas Day, December 25th. They roam the Earth for about 5 days on our cosmic calendar. Then they are wiped out by an asteroid impact on December 30th. Their long reign was just a brief moment. The first modern humans, Homo sapiens, arrived very late on December 31st. On this scale, all of recorded human history, every empire, every war, every invention, every piece of art, is compressed into the last 14 seconds before midnight. Your own life, on this scale, is less than the blink of an eye. The question the child asked was spoken in the final fraction of the final second of the cosmic year. This perspective is not meant to make us feel small or insignificant. Instead, it makes us appreciate how precious and remarkable our existence is. In a universe so ancient, we are here, now, aware and asking questions. We are the universe's way of knowing itself. We are the momentary consciousness of 13.8 billion years of cosmic evolution. When we look at the universe, we realize that stars, like people, have life cycles. They are born, they live, and they die. The star the child pointed to is part of a long lineage. It was not one of the first stars in the universe. The very first stars were born when the universe was only a few hundred million years old, sometime in late January on our cosmic calendar. These first stars were very different from the stars we see today. They were made almost entirely of hydrogen and helium. These first-generation stars were true giants, hundreds of times more massive than our sun. Because they were so massive, they burned through their fuel incredibly quickly. They lived fast and died young, exploding in powerful supernovae after only a few million years. These explosions were incredibly important. Inside the fiery hearts of these stars, nuclear fusion had forged heavier elements for the first time. Elements like carbon, oxygen, iron. When the stars exploded, they scattered these new elements into space, enriching the surrounding gas clouds. From these enriched clouds, a second generation of stars was born. These stars had a small amount of heavier elements in them. They too lived their lives and died, further enriching the cosmos with the elements they created. This process has been repeating for billions of years. Each generation of stars adds more heavy elements to the cosmic mix. Our own Sun is a later generation star, born about 4.6 billion years ago. It contains a significant amount of these recycled materials. This is why it has rocky planets like Earth orbiting it. This story of stellar generations is the key to our own existence. Look at your hand. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood. None of these elements were created in the Big Bang. They were all forged in the hearts of stars that lived and died long ago. We are, in the most literal sense, made of stardust. The star the child pointed to is not just a distant object, it is a cousin. Its story and our story are part of the same grand cycle of cosmic birth, death, and rebirth. For a star like our Sun, the end begins when it runs out of hydrogen in its core. This will happen in about 5 billion years. Without outward fusion pressure, gravity takes over. The core, now helium, begins to collapse. The collapsing core heats up. Heat radiates outward and ignites a hydrogen shell around the core. The star is now burning hydrogen in a shell around a dead helium core. This new energy source is far more intense. The hydrogen-burning shell pushes the outer layers outward. The star rapidly expands. It swells to hundreds of times its original size. The expanded outer layers cool and glow reddish-orange. The star has become a red giant. It will swallow Mercury's orbit. It will swallow Venus's orbit. It may even engulf Earth. Earth will be vaporized by the heat. Inside, the helium core keeps contracting and heating. It reaches about 100 million degrees. Then the helium flash ignites. Helium fuses into carbon. Helium fuses into oxygen. The star now has helium fusion in the core, and hydrogen fusion in a surrounding shell. This gives the star a brief new lease on life. Red giants are less stable than main sequence stars. They can pulsate. They grow and shrink in size. Their brightness can vary. The star loses a significant amount of mass. Gravity at the bloated surface is weaker. Strong stellar winds blow the outer layers into space. The fate of a low-mass star like our Sun is relatively peaceful. But for stars more than 8 times our Sun's mass, the end is spectacular and violent. Massive stars build elements up to iron in their cores. When the core turns to iron, fusion stops. With no outward pressure, the core collapses under immense gravity. The collapse is catastrophic and incredibly fast. In less than a second, an Earth-sized core collapses to a ball a few dozen miles across. The outer layers fall inward, crashing onto the super-dense core. The material hits the core and bounces off. A tremendously powerful shockwave blasts back outward through the star. A flood of neutrinos from the collapsing core helps rip the star apart. This is a supernova. For a brief period, a single exploding star can outshine its entire galaxy. It releases more energy in seconds than our Sun will in 10 billion years. The explosion hurls the outer layers into space at millions of miles per hour. The expanding cloud of debris is called a supernova remnant. It is a beautiful, chaotic tangle of glowing gas and dust. The Crab Nebula is a famous example, a star seen to explode in 1054 by Chinese astronomers. These remnants expand for thousands of years, dispersing and mixing with interstellar gas. Supernovae are not just destructive, they are profoundly creative. The explosion forges elements heavier than iron: silver, gold, platinum, uranium. These heavy elements, along with others made inside the star, are scattered across the galaxy. Supernovae are the primary source of heavy elements in the universe. Without them, the cosmos would be simpler and less interesting. They are the ultimate cosmic recyclers. We have followed the life of a star from its birth in a cold gas cloud to its eventual death. We have seen how stars like our Sun end their lives as beautiful planetary nebulae, and how massive stars explode in brilliant supernovae. This entire cosmic cycle of birth, life, and death is not just an abstract astronomical story. It is the story of our own origins. It is the answer to the child's question, where did it come from? Taken to its deepest and most personal conclusion, the star came from a cloud of gas and dust. But where did we come from? The answer is the same. We are made from the ashes of dead stars. Look at the world around you. The iron that makes up the core of our planet, giving us a magnetic field that protects us from harmful solar radiation, was forged in the heart of a massive star and scattered by a supernova. Carbon, oxygen, calcium, silicon. All of it was created through stellar nucleosynthesis and delivered by these cosmic events. The formation of our solar system, about 4.6 billion years ago, was only possible because the cloud of gas and dust from which it formed had been enriched by many previous generations of stars. It contained the heavy elements needed to form rocky planets like Earth. The very atoms that make up your body were once inside a star that lived and died billions of years ago. You are not just living in the universe is living in you. You are a walking, talking, thinking collection of stardust. You are a way for the cosmos to know itself. So, when the child points to a star and asks where it came from, the answer is a circle. The star came from a cloud of dust left behind by older stars, and the elements that make up the child, the hand that points, the eyes that see, and the mind that wonders, they all came from stars as well. We are inextricably linked to the stars. They are our ancestors. This is not poetry or metaphor, it is a scientific fact. We are stardust, given life and consciousness on a small blue planet, looking back out at the stars and wondering about our origins. This realization transforms our relationship with the universe. It replaces a sense of cosmic loneliness with a profound sense of belonging. Through us, the universe is able to think, to feel, to wonder, and to understand itself. The curiosity in the child's eyes is the universe's own curiosity, looking back out at its own reflection. The light from an ancient star enters our eyes, and the stardust within our brains processes that light into a thought, a feeling, a question. It is a beautiful, unbroken circle of existence. We are not just in the universe, we are of the universe, and that is a truly wonderful thing to be. Our journey has shown us our deep connection to the cosmos, but it has also shown us something else, the preciousness and fragility of our own world. We have traveled across billions of light years and have seen countless worlds. We have seen fiery infernos like Venus. We have seen frozen deserts like Mars. We have seen gas giants. We have seen rogue planets. And in all our searching, we have not yet found another world as vibrant and full of life as our own. Our Earth, this beautiful blue marble, remains a unique and priceless jewel in the vast darkness of space. From a distance, it is just a pale blue dot, a tiny stage in a vast cosmic arena. On this one dot is everything we have ever known and everyone we have ever loved. All of our history, our triumphs, our tragedies, our art, our science, our joys, our sorrows have played out on this small, fragile world. Our grand tour of the cosmos, with its immense scales and epic events, gives us a powerful perspective. It shows us that our national borders are invisible from space. It shows us that our conflicts are petty in the face of cosmic emptiness. It shows us that we are all in this together, passengers on a single spaceship with a shared destiny. This perspective brings with it a profound responsibility. We are not just the inheritors of this world, we are its caretakers. We are the temporary guardians of its thin atmosphere, its deep blue oceans, and its incredible biodiversity. The same scientific knowledge that allows us to understand our cosmic origins also gives us the tools to understand our impact on our own planet. It is our sacred duty to use that knowledge wisely, to protect this oasis of life from the threats we ourselves have created, and to preserve it for all the generations that will follow us. The universe may be full of other worlds, and perhaps even other life. But for now, this is our only sanctuary. There is nowhere else for us to go. Our journey across the universe ultimately leads us back home, with a renewed sense of appreciation and urgency. It teaches us that our most important mission is not just to explore the stars, but to cherish and protect the one planet we know is teeming with life. Our cosmic connection does not diminish our earthly responsibilities. It magnifies them. We have a sacred trust to keep this pale blue dot safe. Our 60-minute journey is complete, but the real adventure is just beginning. The end of this tour is not an end to curiosity, it is the start of a lifelong exploration. The universe is a book of infinite pages. We have only read the first few chapters together. The night sky is now a library. Every star is a story waiting to be told. The questions we have encountered, mysteries of dark matter, dark energy, the origin of life, our place in the cosmos, are not just for scientists in labs. They are for everyone. They are an open invitation to all of humanity. Continue to ask big questions. Continue to be curious. Share what you have learned with others. Take a friend or a family member outside on a clear night, away from the city lights. Show them the Milky Way. Point to a star and tell them its story. Tell them how they are connected to it. The awe and wonder we feel when we look at the universe are not meant to be kept to ourselves. They are meant to be shared. The journey of discovery is the greatest adventure of the human species. It drives us to build new telescopes, to send probes to distant planets, to dream of traveling to the stars. The universe is far more strange, more beautiful, more complex than we ever imagined. It is not a simple, mechanical clockwork, but a living, evolving, deeply mysterious entity. The fact that we, a collection of stardust on a small planet, can even begin to comprehend these mysteries is the most wonderful thing of all. The journey is not over. The greatest discoveries still lie ahead of us, waiting in the dark. Let the child's question echo in your mind. Where did it come from? We now have a beautiful, profound answer. But this answer should only lead to more questions. What else is out there? Are we alone? What is our future in this vast cosmos? Let these questions guide you. Let them inspire you. Never lose that sense of childlike wonder. The universe is the grandest story ever told, and you are part of it. All you have to do is keep looking up.